Okay, so I'm super pumped and excited about, we're going to find the nth degree power series for e to the x, and we're going to expand it about x equals 0. So our function is f of x is e to the x. And remember, we're trying to get this. But we're now going to be able to do this using our shortcuts. So let's start with, first of all, since we're expanding by x equals 0, what is f of 0? Well, that's e to the 0, which we know is 1. But we now know a shortcut for how to get c sub 0. Remember that c sub 0 is f of 0 divided by 0 factorial, which would be 1 over 0 factorial. And I'm actually going to leave it in that form because we're going to be looking for a pattern here in a minute. Then we're going to find f prime. But f prime is e to the x, and f prime of 0 is going to be 1. So that's going to make c sub 1, remember, is f prime of 0 over 1 factorial. So c sub 1 is the first derivative over 1 factorial, which is 1 over 1 factorial. And again, we're going to leave it in that form. So let's do the second derivative. F double prime of x. E to the x again. You should start to see a pattern here. F of 0 would be e to the 0, which is 1. To get c sub 2, remember we do our second derivative divided by 2 factorial. That's 1 over 2 factorial. Then we could go ahead and continue to do derivatives, and we'll get c sub 3. It's going to be f triple prime of 0 over 3 factorial. It's the third derivative over 3 factorial, which is going to be 1 over 3 factorial. Let's do one more, just for fun. The fourth derivative over 4 factorial, but that's going to be 1 over 4 factorial. So here's what we have so far then. P sub n, the nth power series, or nth degree power series, remember, is c0 plus c1x plus c2x squared, c3x cubed, and so on. So we said c0 was 1 over 0 factorial. C1 was 1 over 1 factorial, that would be x. C2 was 1 over 2 factorial, x squared. C3 was 1 over 3 factorial, x cubed, and so on. Now I'm going to back up just so we can see the pattern here. These all have x's except for our first term, but remember, that could be x to the 0. Now we can write this in sigma notation, and this is what we've been practicing. So we're going to go n equals 0 to infinity. And we're going to break this up into parts. So the first thing I'm going to notice, if they all have this fraction, and notice that it's 1 over and then a factorial. We're starting at 0 and we count 0 factorial, 1 factorial, 2 factorial. So that's going to be n factorial. Then we have these x's. X to the 0, x to the 1, 2, 3, and so on. So that would be x to the n. You have to memorize this power series in both forms. You either need to memorize it in sigma notation and be able to expand it to the factorial form, or you memorize it like this in the first one and be able to rewrite it into sigma notation, but you have to know both forms. So that is the power series, and I would make myself an index card so that I can remember and start memorizing that the power series for e to the x is n equals 0 to infinity, 1 over n factorial, x to the n. Now your assignment for tomorrow is I want you to do the same thing I just did for f of x is 1 over 1 minus x. So I want you to find the power series in sigma notation So expand it out like I did. Take your derivatives. Find your C sub 0, C sub 1, C sub 2. Look for the pattern and then write it in sigma notation, because this is also one of the 4 that you have to memorize. All right, so that's your assignment for this evening.